Hello guys, welcome back to my channel Maison African Motives. Still working on engineering science N4. So in this case we have got a question which is on kinematics from the question paper of April 2018. So we just want to focus on the whole question on kinematics so that we see how we can obtain this. That was the first part, 2.1, 2.2 and also 2.3 on projectiles. So everything was actually 15 marks, as we can see. All right, so on the first part here we are given on 2.1 there's an aircraft with an airspeed, that is the speed, okay, of 330 kilonewton. It takes off from OR, that is Tambo International Airport, in a direction. We are given the direction north 35 degrees west. So I'm just going to put like a sketch. Okay, there's going to be a wind. Okay, so let me put a sketch, then we put the actual diagram. This is like where we are having our aeroplane here. That's your north here, your east, your west and your south. Okay, so this aeroplane is going with a speed of 330, that is north 35 degrees west, which means north going to the west. This is your north going to west, which means this somewhere here in between here, that is where we are talking of what, 35 degrees. You are coming from the north in this way, going to the west. If it is west 35 degrees to the north, like it means you are coming from the northwest going to the north, but this one is going this way. So definitely there's an angle in between that is going to remain between the horizontal line and the aeroplane, which is 90 minus 35. Okay, 90 minus 35, guys, that is going to give us 55 degrees. Okay, I'm going to explain this later on. So then there is a wind that is blowing, and it is west 42 degrees to the south, which means as we can have something like this. All right, this is our west and this is our south. So this wind is going in this way. All right, so which means we've got a wind which is going this way. Sorry for that, guys. This is something like this. All right, as we know that this is your west, this is your south. So as we can see, this wind is going this direction, so definitely it is going to extend its course to affect the aeroplane. All right, so our diagram, it is going to look like this. We are going to take this extension. This is a 45, take note, is it 45, guys? Not 45 but 42. West 42 degrees to the south. This is west 42 degrees to the south, which is west going to the south here. So this is 42 degrees. So if we extend using your vertical opposite angles, this is going to be 42 degrees also. All right, so now let us join these two to affect each other. So this is how it is going to look like. I'm just going to use a sketch, guys, like this. Remember, this was our north, our west. We are focusing with this direction. So this was our aeroplane here. It's going this direction, and this we said it's 35, but we are not focusing with this 35 actually. Okay, we are most worried about this, which is 55 degrees. All right, and this is the speed of the aeroplane, which is 330. Yeah, this is 330 kilometers per hour. All right, so we shall have 330 kilometers per hour. So this is for the aeroplane. All right, then remember our wind. So this is where we are having our aeroplane from, and the wind is going to blow, and we said this is what is going to happen here between the horizontal line and positive. It is going to extend. Remember your forces, you take your forces from, like the aeroplane is from this point going this direction, but the wind will be blowing inside, so you extend it. All right, so it is going to look like this here. If we are to have our Cartesian plane here, this one is going to be like this, then it extends. So we shall have an extension, is the one that we want here. This is our extension of the wind. So in between here, like this. All right, so in between, we said on this force that was, on this speed that was there was an angle of 42 degrees. So it is going to be 42 on the other end. So we are worried with this angle here, which is 42 degrees, and the speed is okay, we didn't write this. You see now this issue of not writing everything. Okay, anyways, the speed is 90 kilometers per hour. That's 90 kilometers per hour of this wind. So this is the wind All right, so this is our wind and this is our aeroplane. So something like that, guys. I think it's clear enough. So definitely our resultant is going to be this one from this part here where these two meet here. This is going to be your resultant. I'm going to put this in pen, guys. I hope you're going to see it properly. This is going to be your resultant, the one that is going to affect everything, which is your resultant velocity for the what? Aeroplane. And definitely we need the angle that is the direction in this case. All right, so for the direction, take note, remember this was 35 in between here, the whole of this angle was 35, so there's going to be this angle in between which is created, let's just call it theta, and then there's going to be an angle in between the resultant and the north pole here. There's going to be an angle that is going to be left here, a small angle here, which is going to be, let's just call it alpha here. Let's call it alpha. So these three angles, they are going to give us 90 degrees, 55 degrees, and this angle theta and this angle alpha. This is no longer 35 because 35 was covering from the north up to this line, but now there is a line that has been drawn in between, so it's no longer 35. All right, so why am I giving an emphasis about this? Because on your direction, that is where most of you are going to miss it. Your direction is going to be like this. It's either you are taking from this way to this way, or definitely we have to take it from this way. That is the easiest way. From the north, where are we going? We are going from the north, this direction, to the south, to the west. So your direction is going to be like this, from the north pole going to the what? To the west. So your direction is going to be north, and this angle in between the north pole and the resultant, this angle, we said this small angle is what? Is alpha. So it is going to be north alpha degrees going this direction. Which is this direction? We are going to the west. So that is your direction. And this alpha, we shall talk about this, but definitely for you to find this alpha, since we said these three angles must give us 90 degrees, 55 degrees plus theta plus this alpha must give us 90 degrees. So definitely for you to find this alpha, your alpha is going to be equal to 90 degrees minus 55 degrees minus theta degrees. So we have to calculate theta. So as you can see, theta has to be calculated so that alpha can be determined. So that's the long process that you're going to do. Anyways, I'm just talking about the direction because the resultant is easy. It's just an application of your cosine rule. Remember your cosine rule, guys. But how can we have our cosine rule? Because this angle is not complete. You have to find this whole angle here that is opposing, that is opposite to what? To the side that you want to calculate this RV. So what is going to be this angle? All right, this is a relationship that you're supposed to know about parallel lines because these are north poles. So these lines here, they are not going to meet. This east line from west to east, and this one from west to east, they are parallel lines. So that means this angle here, this angle that I'm indicating here, and this angle, they are equal from your z angles, from your mathematics, guys, alternate angles, these ones which give us a z. So if this is 55, this is also 55 degrees. All right, so easier. So which means this whole angle, now the one that we want, we are going to add 42 plus 55, that is going to be your whole angle, which is 97 degrees, like that. So using this diagram now, we can actually find our RV because we have got a triangle like this where we are given two sides and an angle in between, and you want to calculate the third side. So using your cosine rule, a squared is equal to b squared plus c squared minus 2bc cos a, which means a is going to be the square root of both sides. All right, so that means your RV is going to be the square root of b squared plus c squared minus 2bc cos a, where b and c are the sides that are creating the angle, these two sides, which is 90 and 330. So we shall have the square root of 90 squared plus 330 squared minus 2 times b and c. As you can see, we are repeating the same sides, 90 and 330, like that. Cos of a which is cos the angle in between those sides, and this is the angle in between, which is 97 degrees. All right, just like that, guys. From your calculator, you must obtain your resultant, which is 352,476, something like that, because it's going to be 5, so this is going to change to 6, because it's 558, something like that, so it's going to be 6. This is kilometers per hour, or you can just write per hour, which is with h, or just like that is fine. All right, so that is our resultant. So we have this value here. Let me just put it into consideration, because we are going to need this value, 352, whatever that we obtained. We say it is 352,476, which is kilometers per hour. All right, that's what we had. And we need the direction now for this. And we said our direction, remember what I said about our direction. We said it's supposed to be north alpha degrees to the west. But this alpha, which is this angle, is supposed to be 90 degrees minus 55 degrees minus this angle theta. So you must calculate this theta first, the angle that is inside the triangle. And it's easier because it's inside a triangle. So we can apply the rules, sine rule, to find that angle, because we know that sine theta over the corresponding side must give us that sine theta over 90. The corresponding side must give us sine the angle which corresponds to side, and the only angle that we have is this 97, which corresponds with RV, the one that you calculated. So it's sine 97 over this side, right, which is sine 97 degrees over 352, the one that you just calculated, which is 476. So play around this to find your theta, multiply by 90 both sides. This is just 90, sorry, multiply by 90, so this is gonna cancel. So sine theta is going to be equal to this, so definitely theta is going to be arc sine of 90 times this is going to be 90 sine 97 degrees over 352,476. All right, so that is going to be your theta. All right, so let's find our theta, guys. So our theta is going to, make sure that your calculator is in degrees also. So your theta is going to be something like 14,68077, which is going to be 81 degrees. So this is our theta, but we say this is not our value because theta is inside this angle. It's inside the triangle, as we need the angle between the resultant velocity and the north pole. That is the one that is easier for us. So we need to find this angle here, which is alpha, and this is what we said our alpha is going to be. So we said our alpha is going to be 90 degrees minus this 55 degrees minus this theta that we calculated now, our theta here, which is 14,681. All right, so we subtract this, so that will be your alpha, which is something like 20,319 degrees. Okay, so that is our alpha, which is our direction. So therefore our direction is going to be north alpha degrees, like that, north 20,319 degrees going to the what, to the west. So that is what you're going to have. So definitely, therefore, our resultant, guys, we can just have you can just conclude everything to say that our resultant velocity is the one that we obtained, this one of 352,476 in kilometers per hour. Then the direction is north 20, this is 20, not 30, 20,319 degrees going to the west. So that is what we are going to have now in conclusion of what we have just calculated everything. And we're just calculating, this is actually 2.1, guys. Someone is wondering which part are we actually focusing on. We are still on 2.1. So these are the steps that you're supposed to take. I don't know if we are to get, like, these questions are also, you have got so many ways that you can use. So I also encourage you to try other methods and see if you obtain the same answers as the ones that we are having here. All right, anyways, let's see another question which is on 2.2. On 2.2, we are given another consideration, which is now working with the relative velocities. There are two vehicles which start moving simultaneously. Simultaneously means at the same time. So the other one is moving another direction, another one another direction at the same time. Vehicle P moves at 200 kilometers per hour, and we are given the direction, which is west 44 degrees to the north, right? While Q moves 200 kilometers, so they've got same speed, but this one directly going to the east. All right, so these, which means they are from the same point, because they moved simultaneously here from the same point. So let's just say this is where they are from. This is our north, our east, our west, and our south. All right, so let's start with the first one. The first vehicle, they said it's moving 200 with a speed of 200 kilometers per hour, but it's west 44 to the north. Remember, you're going from west to the north, and this is west going to the north, so it's supposed to be this direction. So it's like this. Okay, guys, you see this show of using hands now. Okay, it's supposed to be straight, guys. Okay, pardon me for that. So this is where it is going. So this is the angle here that you are given, west going to the north, 44 degrees. If it was north 44, it is going to be from the north going to the west, like that. All right, but this is west going to the north. So this is the first one of 200 kilometers, which is your P. So this is your P with a speed of 200 kilometers per hour. All right. Okay, we move on to another one. Let's see. Q is moving 200 kilometers per hour directly to the east, which means this one is moving in a horizontal line in this east line, direct in this east. We've got 200 kilometers per hour. This is our Q. All right, something like that. And what is then we asked to do? Okay, now I'm putting another way. So the question is now to calculate the velocity of Q relative to P. Okay, we need the velocity of Q relative to P. So definitely this one, what you just do is to combine these two guys. All right, so you can just combine the two. All right, like this. All right, so we are going to have here our velocity. We are given to find Q relative to P. All right, so this is Q relative to P, which is going to be okay, so this one is going this direction and also this direction. So we need to find this value, which is of the velocity here, and definitely we also need the direction. So the direction is going to be Q relative to P, so we are going to work with this direction from Q. Okay, so this is going to be our direction, which is from the east going to the what? This is from east to the north, so we can just say this is our theta. All right, so that's it. How can we find now this velocity and this result in this direction? From the concept of a straight line, we know that angles on a straight line, they add up to 180 degrees. So in order for us to have this angle inside the triangle so that we can calculate this velocity, we are going to subtract 44 from 180, because angles in a straight line, they add up to 180 degrees. So 180 minus 44, that's 136. All right, 136 degrees. So guys, this is just a repetition back to your cosine rule, where we applied to the previous part on that resultant velocity. So which means here our velocity is going to be the square root of that formula, b squared, whatever you said, b squared. These are the sides that are creating the angle. So we've got 200 and 200, guys, same formula that we used last time. So it's 200 squared plus 200 squared minus 2 times BC, which is 2 times 200 times 200 cos of the angle that is creating these angles. Okay, these sides, I mean, are created by this angle here, which is 136 degrees. So it's going to be cos 136 degrees. So definitely someone, if he or she is to apply the calculator properly, is going to obtain something like 370, 8735, so it's going to change to 4 in meters. Is this meters or kilometers? These are kilometers actually per hour. All right, then we need to find now the direction. So we are going to need this velocity, which is 370,874. So we are going to need this in kilometers. We are going to need this to calculate what this theta here. All right, so just like what we did previously, we are going to need this because we are going to say sine theta over the corresponding what? Over the corresponding side. Okay, so you can even put it here, it's going to be enough. Sine theta over the corresponding side, which is 200, is equivalent to sine of the angle that we are given, 136, over its corresponding side, which is this value. So it's sine 136 over the corresponding value, which is 370,874. So to find theta, just cross multiply or multiply by 200 both sides so that this can cancel. So sine theta is going to give you this value. So definitely to find theta, it is going to be arc sine of 200 times this value, which is 200 sine 136 degrees over 370,874. So arc sine is just shift sign on your calculator. All right, and this is going to give us an angle of theta, which is going to be 21,9999 and so on, which is going to be 22, because this is going to change to 10, 10, 10, and this will be 2. So it's going to be 22,00 degrees, which is just 22 degrees. That is your direction. But remember, guys, what I was saying, that you are starting from the east going to the north. So it's going to be east theta degrees to the north. And theta, you just calculated it now. So therefore, everything, the resultant, the relative velocity that we are given. All right, let me bring back my question here of Q. The velocity of Q relative to P is going to be this one. Okay, guys, remember, see where I'm writing now. Okay, so therefore, QP is going to be, remember we calculated this velocity and we obtained 370 here. Okay, 370,874 in kilometers per hour at this angle, but we said it's going to be taken as north. Remember, here east to the north, sorry, east theta degrees to the north. All right, so it is going to be east theta. Our theta is 22 degrees, so it's 22 degrees to the north. All right, so that is it, guys, on this part. So these are the stages that actually you need to work on and to try and see how you are what you are given and how are you going to apply that information, because you have to apply it in a proper manner. All right, anyways, let's see another part, which is on projectiles now, where we are given a certain body is projected at such an angle that the maximum height is 2/3 of the range. This is the range. All right, what does the range represent? The range, this is your horizontal distance. All right, the initial velocity is 350 meters per second. Calculate the angle of the projectile. All right, this is what we have. So as you know, guys, on your projectile, I actually encourage you guys to work with your form. This is horizontal. I'm wondering, why am I doing this without even using a ruler, guys? How is this possible that someone can just draw with free hand like this? How is this possible? Okay, anyways, I know some I know you are understanding, not some, but all of you guys, you're understanding me. All right, so this is what is going to happen here, guys. We are given that the maximum height, all right, let's just say h max here is equivalent to 2/3. 2/3 means 2/3, that is 2/3, but of what? Of the range. So it's 2 over 3 of the range. The range is your horizontal distance. So this is your h horizontal like that. Okay, that's your h horizontal. The formulas, so now you have to know your formulas, guys. Remember, your h max, which is your maximum height, can be shortened by this formula. Our h max is equivalent, the maximum distance is given by u squared, velocity here, which is u squared over 2g by sine squared. So it's going to be 2g here over sine squared theta. So you're supposed to know these formulas very, very well, how to apply them. All right, then our horizontal distance here, so you can just put as s, maybe you can understand. Okay, then s horizontal, which is horizontal, is given by the formula. Remember, the formula is u squared g, so it's going to be u squared g by sine 2 theta. So please know how to apply these formulas. This is for the horizontal. This is when it is a maximum. So they are saying this is equal to 2/3 of this. This is your maximum distance. This is your horizontal distance. So we are going to equate these two, okay, by 2/3. So they are saying u squared over 2g sine squared theta is equal to 2/3 of the horizontal distance, which is this horizontal of u squared over g by sine 2 theta. So if this okay, by 2/3, we're going to multiply by 2 over 3, like that. Now it can make sense. All right, so we want to calculate theta. So you've got theta here, you've got theta here. So first, let us try and apply our mathematical skills, guys, to work out whatever we can. Okay, here, if you can see properly here, this is u squared over g. Okay, u squared over g. This is u squared over g. It's the same, so this can cancel both sides, which means I'm going to be left with sine squared theta over 2 is equal to 2 times sine theta, which is 2 sine 2 theta over 3. All right, then how can we win? Now you're supposed to go back to your mathematics, your trigonometry there, identities there, so that we can clear around this. Okay, remember from your identities, guys, this is sine squared theta, and this sine 2 theta, we actually have an identity for this sine theta, sine 2 theta, this one. The identity is that we have this as sine 2 theta from our identities is equivalent to 2 sine theta cos theta. Remember that. So we are going to multiply this. So it's going to be sine squared theta over 2, which is equal, take note here, this 2 is already there, and this 2 is for sine 2 theta in its equivalent identity, guys. Okay, so it's going to be 2 times 2, which is now 4 sine theta cos theta over what? Over 3. All right, now we can cross multiply so that at least we can play around with these mathematical skills, guys. Just cross multiply. 3 times this is going to be 3 sine squared theta. 2 times 4, that is going to be 8. So it's going to be 8 sine theta cos theta. All right, what if we just take these trig values that we are given, the trig values, the sine, the cos, to one side of the equation, guys? What if we can just do that? So how can we do this? This is 3 sine squared theta, which is equal to 8 sine theta cos theta. So you can simply divide by sine theta cos theta, divide by sine theta cos theta. All right, so the moment we do that, we are going to remain with this will cancel definitely. Then this is sine squared, so there are 2 here. So if we divide by 1, we are going to be left with sine theta. And from our identities, we know that sine theta over cos theta gives us tan theta from your mathematics. Okay, so which means it's going to be 3 sine over cos, so it's going to be 3 tan theta. Okay, which is equal to, here we cancelled everything, but we are left with 8. So that means we can make theta, tan theta to be the subject by just dividing by 3 by 3. So if we can have tan theta as 8/3, then our theta can be determined. Remember how you determine theta from sine theta, cos theta? It's arc tan, arc cos, arc sine. So we need theta from tan. So your theta is going to be arc tan on this side. So it's going to be arc tan 8/3. So arc tan from your calculator, that's shift tan. Okay, so it's going to be arc tan, and you're going to obtain something like 69,44395. So it is going to change into 4 in degrees. So that is the theta that you're going to obtain, which is the angle that you're going to obtain, which corresponds with that given consideration when we are given that our maximum height is 2/3 of the of the range, which is the maximum height. And so what you need is to know these formulas. The formula for maximum height, we're working with the horizontal distance and also vertical distance, the velocities that you're going to have, and so forth. I think this can actually help us on this project also. But you see that all of these questions, we have worked on them, and they're just like a repetition, but they are now asking, or they just shift this question to another question, something like that. Okay guys, so that's what we had from this question on kinematics for engineering science and 4. Let us not forget guys to share our videos or to your friends and colleagues, so that they also can be part of the family. They can benefit from this as we are working on revisions and question papers, as we prepare ourselves for the exams which are to come. Till we meet again.